Picture this: 90 million rows sitting in a database across 48 tables. You type one plain English sentence. 30 seconds later, a finished dashboard is looking back at you. And this is it. Not a mock-up and not a demo reel. 6 coordinated charts built from one typed question rendered by a real business intelligence platform called Metabase. We will come back to every piece of it. Here is the roadmap. The analyst bottleneck. The journey of one question through the pipeline. How the SQL earns 100%. How 6 cards get planned. The Metabase platform underneath. And how the whole thing bolts on, without touching your systems. Section 1. The analyst bottleneck. Or, why good questions go unasked. Because to understand why any of this matters, you first have to feel the pain of a normal enterprise database. A sales manager wants to know which customers are most profitable. Today, that means filing a ticket, waiting 2 to 3 days for an analyst, and hoping the query comes back right on the first try. And the analyst is not being slow. This is Wide World Importers, a production-scale database, and it is genuinely hard. 48 tables, 561 columns, 98 foreign keys. Even an experienced developer needs 10 to 20 minutes to write one correct join. Now flip it. You type the question in plain English, and under 30 seconds later, 6 coordinated charts. No ticket, no SQL, no waiting on anyone's calendar. That gap between a 2 to 3 day wait and a 30-second answer is the whole story of this system. So let us open the machine and follow one question all the way through it. Section 2. The pipeline. The journey of one question. Say you ask for the top 10 customers by profit margin. 5 stages stand between that sentence and your dashboard. And here is the actual pipeline, straight from the project. The question enters on the left, the dashboard comes out the right. In between sit schema retrieval, card planning, SQL generation with validation, and the Metabase embed. Stage 1 is schema retrieval. Out of 561 columns, where should this question even look? A vector database called Qdrant acts as a semantic search engine, mapping your everyday business words to the right database views. The matching is layered. Common words go by simple keyword, so revenue points straight at the sales summary view. Unusual phrasing falls through to semantic search, which reads meaning instead of spelling, and keeps only the strong matches. Stage 2 is the planner. Claude Sonnet 4.6 reads that schema context and designs exactly 6 visualization cards, each one a different way of answering your question. More on that in Section 4. Then Stage 3 writes the SQL. 1 query per card, and critically, every single query is validated and tested against the live database before anything renders. The finished cards then embed into the app through the Metabase SDK. End to end, that whole journey takes under 30 seconds. And along the way, it creates no tables, runs no migrations, and changes nothing in your database. Hold that thought, because it becomes Section 6. Section 3. Perfect SQL accuracy. And yes, we need to talk about the elephant in the room. AI models hallucinate, and database queries are exactly where hallucinations get expensive. Our first prototype wrote SQL that looked perfect and then crashed against the real database. A column spelled slightly wrong. A date function from the wrong dialect. Generate and hope failed roughly 1 query in 3. So how does this system claim 100%? Not with one clever trick, with 3 stacked layers. And this figure, straight from the project, shows all 3 of them. Layer 1 is prevention. 14 strict txtSql rules go straight into Claude's prompt. Things like no order by inside a subquery without top. Never mix top with offset and fetch. rules of the road before a single line is written. Layer 2 runs after the model and before the database. 7 automatic post-processing fixes that rewrite the model's repeat mistakes. Stripping markdown fences, injecting a missing over clause. Cheap, deterministic, and invisible. And layer 3 is the safety net. If a query still fails against the live database, the exact error message feeds back into the next attempt, up to 3 tries. The user never sees any of this. No stack traces, no broken cards. Now here's the part that sounds made up. Once the first 2 layers were tuned against real failures, the retry layer stopped firing. In current testing, it simply never runs. And that is the whole philosophy. Build the cheap layers so well that the expensive layer becomes a net you hope never catches anything. The result is 100% SQL success across more than 10 categories of questions. There is one more gate before any query runs. 7 security checks. Every query must start with select or with. Anything that writes, deletes, or drops is rejected flat out. System tables blocked. Injection patterns caught. Read only. Every single time. And if you still do not trust it, good. You should not trust any tool that hands you a number and hides how it got there. Every generated query sits right in the interface, expandable and copyable. Take it, run it in your own tools, and check the number yourself. Section 4. Planning the 6 cards. From raw data to a visual story. Because reliable SQL is only half the job, a good dashboard is not a pile of numbers. It is a coordinated set of answers. The planner selects from 12 distinct chart types: tables, bars, lines, areas, donuts, scatters, funnels, waterfalls, combo charts, geographic maps, and more. It reads the intent of your question and the shape of the data, then composes the mix. And there are rules. All 6 cards must be different types. If the planner returns 2 bar charts, a validator swaps the duplicate for an unused type. And card 1 is always a data table, holding the direct answer to your question. I love this detail. The map card only appears when the question targets a specific subset of customers. So no more useless zoomed-out world map stapled onto a salesperson query just to look busy. So here is the finished product. For top 10 customers with the highest profit margin, 6 cards, 1 story. And every one of them came out of the pipeline you just watched. Card 1, the sortable data table with the direct answer. Then a horizontal bar chart ranking the margins. Then revenue against profit as a line chart for context. Then a monthly profit trend, a donut breaking down the customer category mix, and a pin map of exactly those top customers across the country. 6 angles on 1 question. And look at the bottom left corner. That little badge says Metabase. This is not a picture of a dashboard. It is a live business intelligence platform running inside a React app. Which brings us to Section 5. Section 5. The platform underneath. Because the AI builds the dashboard, but Metabase is what makes it a working business tool instead of a static picture. Metabase is a powerful, feature-rich business intelligence platform in its own right. Teams use it to hand-build custom dashboards, static or dynamic, long before any AI gets involved. Here, it is the rendering engine for everything the pipeline produces. That is why these cards are interactive. Click a bar, and Metabase filters the whole dashboard to that customer. Click a pin on the map, same thing. The AI generates the dashboard. The platform makes it explorable. A saved dashboard can email itself to a distribution list every Monday morning, and an analyst can open any generated dashboard in Metabase's Visual Query Builder, add a filter, change a chart type, and refine it by hand. Enterprise access control lives on the platform too. Row-level security means two people can open the very same dashboard, and each sees only the slice of the data they are allowed to see. And it is not a one-query toy. Here is the Save and Load drawer. 25 saved dashboards organized by category: customers, sales and revenue, salesperson performance, products, geographic. Saved dashboards store the recipe, not the rows. Load one, and it reruns the queries against the live database. So the dashboard a manager saved last quarter shows this quarter's numbers today. Speed comes from a 3-tier Redis cache. Finished dashboards for a day, query templates for a day, raw results for an hour. Ask the same question twice, and the second answer skips the AI entirely. It comes back in under 5 seconds with fresh data. Section 6. The bolt-on architecture. Because the first question every engineering leader asks is, what does this thing want to do to my systems? And the answer is, nothing. Here is the architecture figure from the project. The whole system sits beside your existing stack as an independent service, and it talks to your database through a strictly read-only connection, whether that is SQL Server, PostgreSQL, or MySQL. It never touches your base tables. Every query goes through database views prefixed with _v. The views are the front door, and they are the only door. Your database does not even know the system exists. No tables created, no migrations run, no schema changes ever, and it is portable. Point it at a different database, create views exposing what you want queryable, and the same pipeline adapts. In production, this version runs as 4 services: the React app, the Fast API backend, the Metabase server, and Redis. Your existing application keeps control of login and navigation, and simply embeds the rest. Which brings us to the line that reframes this whole project. The ROI of natural language dashboards is not measured in analyst hours saved. It is measured in questions that were never asked because the friction was too high. Think about that for a second. Every organization has hundreds of questions sitting in the gap between curiosity and capability. Remove the weight, remove the SQL, remove the friction, and you change what people even bother to ask. This system was built to bolt onto your data. So if your team keeps asking a database questions and keeps waiting days for the answers, message me. This is exactly the pipeline I build for clients. And here is the question I will leave you with. How many unasked questions are sitting in your database right now, just waiting for the friction to disappear?